RKA. So, would you be able to figure out the area of the square with just this information? Nice to meet you. I'm Leo Sacramento, a math teacher. Here, we solve math problems almost every day on our page, right? So, before I start, I know it's annoying, I know it's a hassle, but it's important, guys. It's important for us to keep growing and increasing our engagement, and for more people to get to know our work. So leave your like, subscribe to the channel, share with your friends, and comment. If you like the solution or if you solved it in a different way, let me know, because it's also important for me to read all the comments and reply to everyone. So guys, let's get started. It's really simple. He gave me these dimensions here, and he wants to know the area of the square. Simple, quick, and straight to the point. No beating around the bush. Guys, pay attention. This part is really interesting. When we look at it, there are pieces of segments here. So what am I going to do? I'm going to connect the top red segment to the bottom brown segment. In this case, I'm going to draw the diagonal of the square. So take a look here. When I draw the diagonal of this square, which I'll call D, let me mark it here in purple, D, we already have an extremely important piece of information. Guys, there's not much else to do here. Another thing I can. Now, let's take a moment to think about what we have here. Let's go ahead and carefully name these four vertices A, B, C, and D. So, looking at this specific line segment coming directly from vertex D, which is the one highlighted in brown, I'm going to go ahead and extend it further out. So, by extending it, let's imagine it reaches up to here. Alright? And now, check this out. It's pretty interesting. I'm going to draw a segment parallel to this green segment. And now, look how cool this is going to be. When I draw the parallel, it will come down to about here. So let's bring this segment down here, parallel to the green one. And then we know that if it's being, oops, that didn't turn out well, let me erase it and do it a bit better. A nice neat parallel warning. That's better. So if it's parallel, it's following the same angular conditions as the green segment to the brown segment. What does that mean? This essentially means that we have a perfect 90-degree right angle right here. And if you look closely, notice how very interesting this is. This specific section down here, extending all the way up to the point of intersection, also measures exactly 6 units in length. And this green section here measures 8. So look at what I just did, guys. I'm going to draw it here for you. We have a right triangle where this side measures 8, this one measures 16, and this one is exactly the diagonal of this square, which I call D. Pythagoras' theorem. So it goes like this. The length of the hypotenuse squared is equal to the sum of the squares of the lengths. Alright? So D squared will be equal to, I have to admit, I forgot. 16 times 16. Let's do it real quick here. 6 times 6 is 36. Carry the 3. 6 times 1 is 6, plus 3 is 9. I skipped the first one. 6 and 1. This is going to be 6, 9, 1, 5, 2. 256. Guys, what's the answer? 64. So the value of g squared, this will be 256 plus 64, 4, 6, 0, carry the 1. 5 plus 6, 11, 1, 12, carry the 1, 3. 320. Therefore, the length of this diagonal is, at this point, I'm not going to factor it. I'm not going to do any of that. Alright? Well, another important thing is, when we have the diagonal of a square, I know that the length of the diagonal of the square is the length of the side of that square multiplied. That's why it also comes from Pythagoras, okay? But I'm not going to do that here, so we can save a little time solving this problem. So what am I trying to say? I'm trying to say that the diagonal of this square is the specific length of the vertical side of this geometric square, simply multiplied by itself. But since we have already carefully calculated that the diagonal measurement is exactly this value, then right here in this instance, it will definitely be the same result. The L square root. Oops, it didn't show up. Sorry, square root of 2. Dividing both sides then, L will be the square root of 320 divided by the square root of 2. When we have division of square roots, we can keep the root and divide the numbers inside. So the length of this side will be 320 divided by 2. That gives 160, but under the square root. So this will be the square root of 160. You might be asking me again, Leo, aren't you going to factor this? No. Why not? Because the area of a square is the length of its sides squared. So the total area of this geometric square will be calculated as the square root of, and what exactly happens here? Just take a moment to look at this incredible mathematical magic. Beautiful, I canceled it out. This ends up being 160 square units. So that's the solution to this problem. And we figured out the area of the square just using the segments. Did you like it? Leave a comment here so I know what you think. And honestly, I hope you all enjoyed it. I made this video with a lot of care. And right here, the subscribe button is going to pop up. If you haven't subscribed yet, it's important. It helps us out a ton. And here's another little video recommended for you to watch another one of my lessons. Thank you so much for sticking around until the end.